What's up, everybody? My name is Joe.
My name is Mike.
And basically, we're going to go into the lab today, and we're going to be showing you a little bit about the instruments that we have in the lab, specifically the UV-VIS.
Yes, we're going to have schematic drawings for you guys in the beginning, and then after the schematic drawings, we're going to show you the actual instrument and be able to show you all the components of it.
Yeah, so before we get started, make sure to click the like button for us, subscribe to our channel.
And please
it
share
really
to your
helps
friends.
us. Yeah, share this video if it helps you at all. So basically, what we're doing now is we're going into the lab where we're going to be looking at the instruments that we have here. The simplest UV-VIS design is that of a Spec 20. It uses a single source, which is white light that comes from a tungsten halogen bulb. This light passes through a filter or a monochromator which selects specific wavelengths in which you want to look at the sample. The light then either passes through the reference cell or the sample cell, not both of them because this is a single beam pathway. The sample that passes through the reference or sample cell that doesn't get collected by the sample is then detected through a photodetector or a phototube, also known as the transducer. This signal is then amplified and displayed on a readout screen. So these are the inner workings of our Spec 20. This is a rather older model, so it's been taken apart with the case outside of it. So basically, our source is back here, and I can't actually take it out because it's underneath everything. And the light travels through this tube that has a slit in it, and it focuses the light. And then over here is the monochromator, which can be changed by moving this, the wheel. You can select which wavelength of light you want to pass through the sample, and then it bounces off the monochromator through here. And then when you have a sample in the cell, it pushes that up, which usually blocks the sample. It allows for the sample to shoot through the thing, and another slit right there focuses the light. The light passes through your sample or reference, and then it's collected by these phototubes. The signal from the phototube is then brought into all the rest of this hardware and then displayed out on this screen. All this hardware back here is used to take the signal from the phototubes, amplify it, and then give it a numerical value, either percent transmittance or absorbance. This is a single beam instrument.
This is the Alfred double beam instrument design Perkin-Elmer Lambda 4B UV-VIS. It is a classic Turner design. We first start off with a source that contains the deuterium lamp and the tungsten halogen lamp. The deuterium lamp sends out a UV light, and the tungsten halogen lamp sends out a visible light through a filter which contains three components. The color wheel, which selects the type of light that it wants to analyze through the sample, and then it goes through a variable slit, which is then focuses on the light, and then it hits a X-light monochromator, which acts as a wavelength selector controlled by a worm drive to select a specific wavelength. After it passes through that monochromator, it is then goes through a optical chopper, which is right here, represents over here, and to be able to split the light into two, and each light will then go through a reference cell and a sample cell. Now the optical chopper forms two lights, hence the double beam design. Each light would then hit a mirror and passes through a photodetector where it's being detected by a photomultiplier tube. The photomultiplier tube then creates a current, which is then amplified by the instrument and will be displayed on a readout screen. Hello everybody, I'm going to be showing you one of Alfred's double beam instrumental design, the Perkin-Elmer Lambda 4B. We named this instrument right here called Dharma. So I will be opening up Dharma and you will see the components of Dharma. Now Dharma has very special components. First we have our tungsten halogen lamp and then our deuterium lamp, which sends out the light that I mentioned before into our color wheel. The color wheel would then push the light into this hood, and under this hood we have our variable slit and our echelon monochromator, which is right here. The variable slit helps focus on the light, and this light would then hit the mirror, and in the mirror will push the light through the echelon monochromator, and then the light would be selected. The light's wavelength will be selected by the echelon monochromator, and then it will pass through a mirror right here, and then the mirror pushes the light into the optical chopper, which the light gets split into two, and then the light would then go through the reference cell or the sample cell. And we usually have a cuvette ready for us, prepared. One will go through the reference cell, and the other will go through the sample cell. And the light would then pass through these cuvettes. The light would then go through a photomultiplier tube, which the photomultiplier tube detects and creates a current so that it can be amplified by the instrument at this section right here. And after the current is amplified, it will then be read out into this computer screen. And you can see how it says Dharma. This is our...
Here's a schematic drawing of the lambda 25, 35, or 45. It is the most advanced type of UV-VIS, yet the simplest. There are a few key differences in that of the lambda 4B. The light sources are, however, the same. They're bounced off a few mirrors, through a slit, and then through the monochromator, which is a holographic monochromator, which allows for this instrument to not need a chopper or a color wheel, because it focuses the light better and it causes for a specific wavelength to be read. It is then sent through another slit where it is split through a beam splitter, and the two beams of light then pass through the reference cell and the sample cell and are detected through a photodiode detector, which then converts the light to a current and sends it through the instrument to be amplified and read out on a screen. Alright, so this is Alfred State's Lambda 35, and I'll be showing you the inner workings of this guy. His name is Vinny, rather than the Lambda 25. The only difference between the Lambda 25 and the Lambda 35 is that the slit for the 35 is variable and the slit for the 25 is fixed. So basically, I had to remove these two screws in order to get the hood off. You have to first open this guy, and then the whole entire hood. And as you can see, it looks a lot more simpler than even the Lambda 4B. But I'm gonna take off the black casing. Basically, this black casing just doesn't let any of the light escape while it's being run through the instrument. Now, our light sources are exactly the same. The deuterium lamp is back there, and that's back there. We have a few mirrors right there, which then bounce it over here. And I'm gonna take this off. And basically, here's the variable slit. It then passes through the variable slit, and this is the monochromator, the holographic monochromator, which is still worked by a worm drive. It is then passed through over here, where another slit, if you want, it depends on what program you run, is right here. And then there's the beam splitter, which will send half of the beam that way and half the beam this way, bounces off these two mirrors, and then it's sent through here. Now, we're gonna use the exact same cuvettes. Quartz cuvettes are probably the best. You put the reference in there and the sample in the front, and instead of having a photomultiplier tube, this instrument has a photodiode detector, The current from the photodiode is then amplified through the software of the instrument and read out on a computer screen that you use a specific program for. So now that I showed you the inside of Vinny, we're gonna seal him back up. I just put this hood back on and I'm securing these little guys over here. I'm gonna close this and I'm gonna re-screw back in these screws. Obviously, I'm not gonna show me putting them all the way in for this video, but you get the gist. So when I have the screws all the way in, you're gonna take your cuvettes that have your samples in. The side that has the grating on it, you're gonna want to be vertical so that the light that passes through goes through the clear side. So I'm basically putting those in. Let's pretend like there's a solution in them. You have to have the little caps on. And basically, when you're running the instrument, it'll already be on and the lamps will already be on and everything. And every time you put your sample in here, you have to make sure that this door is closed to cancel out any extra light. When you have your method running and everything, you'll get your results on the screen and then you can analyze your results like that.
Okay, everybody, as we said before, please like and subscribe to our channel, especially if this helped you a lot. Also, please share this to your friends and your family. Thank you for watching. We out.